Hi everyone, thanks for watching the video on angle pairs. This video is going to talk about the relationships that exist with the angles that are formed with parallel lines. I want to start out by looking at this kind of key idea that's going to guide our thinking today. And if you look at the parallel lines that I've created here, this space in between them, we're going to consider that the interior space. And then everything on the outside of those lines will be considered the exterior. Okay, so if you take any two lines, and they don't even have to be parallel, but if you just take any two lines like this and draw a third one through the lines, and you can have more than two lines, but if you take even at least two lines and you draw the line through them, this line that I'm going to label with the T, this one here, and again, I'll highlight that one. Let me change my pen thickness. There we go. Okay, so this line and this line are considered transversals. So if you want to fill that in here, a transversal is basically just a line that crosses through two or more lines. Okay, so M will never cross N. So since M only touches one line, which is line L, you can't call that a transversal. Nor can you call line N a transversal because in this diagram it only intersects one other line. So maybe think T for 2 for transversal, 2 or more. Transversals have to touch, here's one, here's the second. So they got to hit at least two lines. In this picture, what we've created is an image with two parallel lines, and we learned yesterday that if they're parallel, we should mark that in the picture by putting these arrows right here on the lines. All right, notice I didn't put them on the end. You kind of want to put them in the middle. Kind of label them in the middle, or at least just not on the ends. And when you see these arrows, that indicates that they're parallel. You could even have more of these, but they have to match. So if there's two arrows on this set, there should be two arrows on this set, and they generally face the same direction. You're not going to go like one this way and one that way. That's just, it's not going to happen, okay? If you mark it that way, it's not the correct notation. So really focus on making them match and face the same direction. All right. So if we look at this picture, the vertical angles, remember, if you look at, I'm going to think of this as like a cluster. So on this cluster of angles, the vertical angles are going to be the ones that are across from each other. So I'll just give an example here and add this into your notes. So angle 1 would be congruent to angle 4, and that's because vertical angles are congruent. All right. We could say 2 and 3 are vertical angles. And again, I'm going to put that equal sign with the little squiggly. That means that they're congruent. So 2 is congruent to 3 because they're vertical, and vertical angles are congruent. All right, linear pairs are basically a supplementary set of angles that are adjacent to one another. So we can look at, I'm going to get rid of some of our highlighting here. Any consecutive angles that are next to each other that share a vertex, like 2 and 4, would be considered a linear pair. So those ones would not be congruent, but they'd be supplementary. Okay. So what I'm going to encourage you to do, let me double check to make sure I'm on the right page here of my notes. Yeah, it was on here. Okay, what I want you to do on this picture is to color code. So pause the video, and if you didn't get crayons at the beginning of the lesson, I want you to get those now. And what we're going to do, once you get your crayons, is we're going to think about creating two different clusters of angles. And I'll just pick two different colors. So I'm going to color mine, I'm going to go yellow. So what I'm going to have you do on this color coding is pick the first angle and then the vertical angle. and use the same color combination. Okay. And so those two are colored the same because they are congruent angles. So what I'm going to do is take this and group it here. I'm just going to do this digitally. So basically what we're going to do is take this color scheme and copy it down below. Whoops. That's not what I wanted. There we go. Copy it down below so that the larger obtuse angles have that same pattern where the top left and bottom right have the same coloring. Okay. The other colors you can either leave blank or you can color them in with a different color. But I love doing this. Well, first it's kind of fun to color. But I like it because it shows you a nice pattern here. So anything with the same color, this is an important note. I would write this down. Anything with the same color these are going to be congruent angles. All right, anything with a different color set will be supplementary. All right, and this is all under the premise that if we have parallel lines. If we don't have parallel lines, this relationship doesn't hold true, but if we have parallel lines, this is always going to be true when we look at this setup here. So I'm a big fan of the color coding. You don't have to, but for those of you that are visual thinkers, I think this will help. Okay. I think that's it for this right here. Okay, so now we're going to get into the four patterns we're going to learn about today. Why do we pick these patterns out? Well, a lot of times when we're working on our bridge, the truss designs, when we're working with construction and engineering, we don't want to have to label the pictures with a whole bunch of information. It's visually overwhelming. And anytime you're looking at like construction plans and creating those plans, we want to keep the diagrams as clean as we possibly can, which means we label enough information to communicate the dimensioning and sizes that we want, but we don't over label so that it overstimulates or over informs the reader of the plans. It's visually overwhelming. Okay, so what we're going to look at is this set here. It's called alternate interior angles. And if we kind of focus on, using the English language to help us out here, interior. Well, that means we are focusing on angles that exist only in between the lines that are parallel. So here, 4 and 5 are definitely in between those two parallel lines. All right. Alternate means, if we look at the transversal, alternate means there's one number on either side of that transversal. So let me get a little bit thinner pen color. Okay, so if I trace this line, that didn't work. Okay, you can see that the 4 is above the line and the 5 is below it. Okay, so let's see. Alternate interior angles are two angles that lie on the interior of the, or you can even say in between, whatever makes more sense, in between the parallel lines and on opposite sides of the transversal. Okay. Another pattern I want to point out here is if you have a diagram, and I'll just go to the next page here. Maybe. Where did that go? There it is. Just took a minute to load. Okay, so These green ones are alternate interior angles. And so what I'm going to do is just trace, starting at the vertex, I'm going to trace the edges of the green angle. So if I trace these two edges, that creates the angle. Okay. If I trace these two edges, that creates this green angle. Well, you should notice it forms kind of like a zigzag. So alternate interior angles always form kind of like a Z or a kind of zigzag pattern, which means go in this direction. See, like this one and this one. That forms a Z. So those are alternate interior angles. All right, so that's what I was trying to trace here. See, the 4 and the 5, the 3 and the 6 are alternate interior angles. And as long as these two lines are parallel, then you can see even just on the equation here, you can, and just even looking at them, then alternate interior angles are congruent. And I can't type today. Here we go. All right, that's a big one. Going back to our color coding, that would be like 3 and 6. See how they're the same color? They're congruent. 4 and 5 would be alternate interior angles, and they're congruent. Okay. The second pattern we're going to look at are, I call them like opposite corners. I mean, that's not a formal name, but we'll just say, well, alternate exterior angles are on opposite corners. Okay, we can see that they lie on opposite sides of the transversal. And if you look at the parallel lines, I'll trace those in a color here. See this one and this one. These angles are on the exterior. Okay, so they lie on opposite sides of the transversal and on the exterior of the parallel lines. Sometimes the lines won't be parallel, but the other two that we're dealing with, the other two lines create the interior and the exterior regions. They'll always be on the exterior. The visual pattern on this one is they form V's. And again, I wrote this here, they're located on opposite corners. If we go back to our color coding, that would be like 7 and 2. So you can see they're the same color. They're going to be congruent. 1 and 8 are alternate exteriors. So they are going to be congruent as well, as long as the lines are parallel. So two lines that intersect are, if those two lines are parallel, then alternate exterior angles are congruent. Please write the full word out here. These key ideas are the ones that are going to be used the entire unit for this, for this lesson, okay? Okay, on to the third pair, corresponding angles. I'm going to go back to my little GeoGebra drawing here. And I'm going to highlight, well, let's just clear the ink. There we go. So let's see, we did alternate interior. We didn't do alternate exterior, but that's a pair. And so would this set and this set. Those would be alternate exteriors. The one we're going to look at right now are called corresponding. And so corresponding angles, I think about it in terms of like locations on each cluster. So like if we create a cluster of angles here, there's 4 angles there. There's 4 angles there. These are both in the top right position. So they correspond. They're basically in the same location. Like this one here and this one here would be considered corresponding because they're on the top left. This one and this one would correspond, and so would the bottom right, and the bottom right. So corresponding, I think, are pretty easy to identify. They're harder to define, which is why I wrote it in. Notice one of them, if you look at your parallel lines, one of them is in between there, and the other one's on the exterior. They do lie on the same side of the line, so if you draw the transversal in, they're on the same side of that. If you trace the edges, it kind of forms like an F. Like here, if you trace the edge here, and then I trace this angle. Now, this one's an upside down F, but if you trace those angle sides, it will form an F. Corresponding always form an F. So if these lines that intersect the transversal are parallel, which in this case they are, then corresponding angles are congruent. I don't know what that 9 is. That's a typo. All right. The last one is a little different than the others because so far everything's been congruent. The only other set that we're going to focus on would be same side interior. And same side interior angles, I think, are pretty easy to identify because they form like a C pattern. Or if it looks like this, it's more like a U shape. But I always think about it like, where would the cobwebs form if you drew a U? Well, they'd form here and here. So corresponding angles are like where the cobwebs form on a C or a U shape. If you trace the lines in the picture, see there's a C or a U. Okay. They're not congruent, and I'll prove that to you here. Let's look at some same side interiors. All right, and this actually has an angle tool for me. I'm going to measure this angle, and right now it's 60 degrees. And then I'm going to measure the green angle, and that's 120. So you can see they're not congruent, but they definitely are. They definitely are supplementary. So even if I move this around, 148 plus 32 still adds up to 180. Okay, if I move it again, oops, I don't want to do that. I want to do this one. There we go. 89 and 91, still supplementary. One's getting bigger, the other gets smaller. All right, see that? Kind of like the parallelograms that we drew with the robots. That's the same concept. These consecutive angles are supplementary. So it's almost like if I drew in this other side, there, boom, you got your parallelogram. Well, everything's connected. All right, so on this one, as long as you have parallel lines, which we generally are going to in this class, as long as the two lines that touch the transversal are parallel, then same side interior angles are not congruent, but supplementary. So at this point, what I'd like you to do is go to the exit ticket page. I want you to complete that, and your job is to turn that in to either Mr. Cross, Mr. Long, or myself. And this is our way of showing or us knowing that you have an understanding of what you learned today. Thanks for watching.